9.2, building an equation for a line. The image shows a line. And then they give the graph, and it's clearly, it's a linear function. And I can tell that because it's got a constant rate of change, up 2 over 1, up 2 over 1, up 2 over 1. So that's a constant rate of change. It must be a linear function. So they want us to write an equation that says the slope between the points 1, 3, and xy is equal to 2. So remember our equation for slope, m equals change in y over change in x, or rise over run. So we know the slope is 2, so I'm going to plug in 2 for m. And now I need to find my change in y. So my change in y is going to be my first y coordinate, or my top y coordinate y, subtracted by 3. If you look back in 9.1, right, when I wanted to find my change in y here, I took this y coordinate 2, and I subtracted -6, and that gives me my change in y of 8. I also could have stacked my coordinates, but this really shows the calculation that's going behind that. So that's y minus 3. And then for my change in x, I'm looking, if I'm trying to find the difference between x and 1, that's x minus 1. So if we just knew the values of x and y, we could plug them in here, and that would be equal to 2. All right. Look at this equation, y minus 3 equals 2, parentheses, x minus 1. How does it relate to the equation you wrote? Well, if I've got, and I'm going to write this same equation, but since it's an equal sign, I can really, doesn't matter which side everything's on, I can write it as y minus 3, x minus 1 equals 2. Those are the same equation. If I want to get y minus 3 alone like I have here, I have to get rid of this denominator. So to get rid of that denominator, I'm going to multiply the entire equation by it. So I'm going to multiply my entire equation by x minus 1. If I do that, this x minus 1 and this x minus 1 are going to cancel out. So that means on my left side, I'm going to be left with y minus 3. When I multiply this side, so actually maybe I'll write it like this to make it a little clearer. When I multiply this side by x minus 1, I get 2 times x minus 1. So all we did was we got rid of the denominator here. We multiplied both sides by x minus 1, so that's the exact same equation. They're not the exact same, but they're equivalent. Great. Here's an equation for another line. Y minus 7 equals 1/2 x minus 5. What point do you know this line passes through? Well, if we look at our first one, if I have minus 3 here, that means the y coordinate here is 3. X minus 1 means I go through the point x equals 1. So if I'm using that same train of thought here, I know my x coordinate is 5, my y coordinate is 7. What is the slope of this line? Well, I know from my previous problem that when 2 was my slope, 2 ended up as the coefficient in front of this binomial. So here my coefficient is 1/2, so I know my slope is going to be equal to 1/2. 3. Next, let's write a general equation that we can use for any line. Suppose we know a line passes through a particular point, h comma k. Write an equation that says the slope between x, y, and h comma k is m. So we're using the same train of thought we used up here. We know that m is equal to change in y over change in x. So they're not giving us the slope, they're saying it's m, so I'm going to keep it that way. Now if I want to model my change in y off what I did up here, I'm going to keep that y the same because we're still looking at a point x, y. But now I don't know the y coordinate of the other point, I just know it is k, so instead I'm going to write y minus k. Do the same thing for x now. I knew the x coordinate was 1, so I wrote x minus 1. Now I know the x coordinate to be h, so I'm going to write x minus h. So that's our equation for the slope here. All right, my change in y, really, my change in y over my change in x. look at this equation, y minus k parentheses equals m parentheses x minus h. How does it relate? So we're going to do the exact same thing we did before. I'm going to take my equation, and I'm going to multiply both sides of the equation by my denominator, x minus h. They'll cancel out on this side, and I'll get x minus h times m, or just m, x minus h. All right, the commutative property tells me that doesn't matter what order I the commutative property tells me it doesn't matter what order I multiply these two in. These are canceled out, so I'm left with y minus k. And that is exactly the equation we got here. So all we did was multiply both sides by that denominator, x minus h. All right, that's all for 9.2.